Welcome to SanfordFlipMath. This is PreCalculus. We are doing graphing trig functions, and specifically we are graphing the trig functions other than sine and cosine. So we're talking about tangent, cotangent, secant, cosecant. We are in section 4.5 in the PreCalc book by Demana, Foley, Kennedy. And this is kind of like installment 2 on this, so we gave a lot of background for where things come from, and this time we're just going to kind of focus in on some specific examples. So we're going to do y equals 3 tangent 2x. We're going to graph it, and then we'll answer those descriptive questions. We'll talk about the main features of the graph, the function, and we'll do this for probably, I don't know, a few more functions. We'll see how many. Okay. All right. So just a reminder that I'm going to start with doing just y equals tangent of x, and we'll do that in blue, and then we'll adjust it. Okay. So quick little reminder based on the unit circle. Again, okay, that was a little too many parentheses there. Remember, tangent is y over x when you're talking about on the unit circle, and I'm not going to spend a lot of time doing this because we did this in 4.5a. But the idea again is tangent is like slope. So the slope at 0 degrees is 0. Okay, and I'm going to mark this one as pi over 2, also known as 90. Okay, and as we go all the way to 90, the slope here would be 1 over 0, or undefined. So at 90, we have an asymptote. As we continue wrapping around, at 180, we're back to a horizontal line, so the slope is again 0. So at pi, we're back to 0. And at 270, we're back to vertical, so that's back to undefined. So undefined slope, we're going to represent that with an asymptote. And then if I'm just going to try and squeeze one more on there, if we get to 2 pi or 360, we're back to that 0 slope again. And so 2 pi would be somewhere about here, and we'd be back to 0. Okay. Okay. And just for those of us that are a little more about the symmetry thing, if I come back to negative pi over 2 or negative 90, again, negative 90 is going to be back at vertical. Okay. The only other points that I need to see, you know, teachers look for certain things, and that's if we're at 45 degrees, also known as pi over 4, that had ordered pair square root of 2 over 2 square root of 2 over 2, and so if I do y over x for that, since x and y are the same, that means that the tangent of pi over 4 is going to be 1, and I'm going to make this 1 that negative 1. So the tangent of pi over 4 is going to be 1. And so those are going to be kind of my anchor points. 0, 0, pi over 4, 1, negative pi over 4, negative 1, and the asymptotes. Okay, so I need to see for a tangent graph, and similarly for cotangent, that's how much I need to see. And we can just kind of copy that cycle, that period over here, and I'm good with this. Okay, if you want to, yeah, I should have went just a smidge farther on that 2 pi, sorry. Okay, so if you were going to include that point, sorry, I have to click somewhere else, but I have to do it with the mouse. All right, if I'm going to include that point, there it is. All right, so that's plenty. I have more than 2 cycles. Okay, now worth noting that this has a 3 in it. So that means I'm going to multiply all of my y values by 3. So this gets multiplied by 3. Okay, and I know that's kind of a cheat, but it's the easiest way to make this happen. Now you can scale like that before you start graphing, or you can just kind of fix it after the fact. I'm kind of partial to thinking in terms of tangent and then fixing it after. So I'm doing a scale change, and I'm doing that by changing the scale. On the inside, remember inside inverse, it actually divides the x's by 2. So this is now, it was pi over 2, now it's pi over 4. This was pi, now it's pi over 2. I'm just dividing by 2. 3 pi over 4, 2 pi over 2, also known as pi, negative pi over 4. I'm done. This is it. Okay. All right, so that's the graph in all of its glory. Okay. So let's answer some questions. Okay. Domain is ugly. Domain is everything except wherever the asymptotes are. Well, let's kind of make a little note here. The first asymptote, and I generally start at 0, 0, and then go to the right. The first asymptote's at pi over 4. The next one is at 3 pi over 4. Well, the next one would be 5 pi over 4. Well, I can't just write that because that doesn't allow for the negatives, and then, you know, what's this, etc., and all that kind of stuff. Well, what I can write is pi over 4 plus how far are they apart? Well, when I went from here to here, I added pi over 2. I'm sorry, I did. I added 2 pi over 4. Sorry, 1 pi over 4 plus what is 3 pi over 4? Okay, let me write that again. 2 pi over 4. Well, from 3 pi over 4 to 5 pi over 4 is again plus 2 pi over 4 plus 2 pi over 4. I'm going to reduce that and call that pi over 2. So my domain is pi over 4 plus multiples of pi over 2. So this number is how far apart they are. This is where I start. Now, you don't have to start at this one. You could start at any of them. You could start at negative pi over 4. You could start at 3 pi over 4. Most of the time, people start with this one and then talk about how far did they go to get to the next one, etc. Okay? Not the only way to write it. Let me just write it one more way. If you notice, this is like 1 pi over 4, 3, 5. Those are odd numbers. So you could write x not equal to pi k over 4 and make a little note that k is odd. In this one, it is assumed that k is any integer. Okay, and just a reminder that integers are numbers that are not fractions, not decimals. Okay, so they are like whole numbers, only positive or negative. So while I'm here, I'm going to go ahead and write the asymptotes. It's x equals those numbers. Okay. All right, so let's look at range. Well, looks like the y values go all the way up and all the way down forever. So I'm going to say, and there are no breaks, range all real numbers. Okay. Amplitude. Well, remember, amplitude is max minus min over 2. Well, there is no max. There is no min. We talked about this on the last one. Amplitude, well, there is none. Or if you want to say infinite because it goes up to infinity and down to negative infinity, that's fine. Okay. Okay, just a reminder again that tangents period normally starts out at pi. Well, so it's going to be pi over b this time. Well, in this case, the period would be pi over, here's b, 2, so pi over 2. Okay, and that's it. We aren't going to talk about vertical or horizontal shifts. They work the same way, but we're not going to do them because the graphs are, dare I say it, ugly. Okay? All right, so some basic quick adjustments to the rules for sine and cosine. There is no amplitude. Period is pi over b, or 180 over b, instead of 2 pi for tangent and its reciprocal. And we're not going to do shifts, although they work exactly the same. It's still negative c over b. It's still d for phase shift and horizontal and vertical shift, excuse me, respectively. Okay, let's do another one. Let's do y equals 2 cosecant of 5x. Okay, well, cosecant is based on sine. So I'm going to graph sine first. Okay, and I'm going to do the same kind of way I always do. So this is 0, 2 pi, pi. This is the parent function, and then I'm going to adjust it. Okay, 3 pi. I'll go with the 4 pi here. So there's my 2 cycles. I'm going to go up to 1, down to yeah, I'm going to go up a little higher. Okay. And I know some of you are saying, is he going to do some on the left? All right, I'll do one on the left just for you. It's funny how people are different and they just see things differently, and different things bug them. Like if I go on and on this video. All right, so that's sine. I'm going to make this into cosecant. Okay, so the next graph is going to be cosecant, and remember that this is the reciprocal of sine. I would recommend drawing what I just drew. Okay, and you can debate about scale issues and stuff. I'm going to fix those in a minute. But if it were me, I just do a quick sketch of sine. And again, if what I'm about to do, if you need to go back to the other video, take a look at it. Okay, so again, what I'm doing is the reciprocal of sine. So these y values are the sine values. So I'm going to do the reciprocal of them. Well, the reciprocal of 0 is undefined, so that's now an asymptote. The reciprocal of 0 is undefined. So here's another 0. The reciprocal is undefined. So any place that this thing crosses the x-axis is now undefined. And anything undefined is going to end up as, you guessed it, an asymptote. Okay, these are not point discontinuities, they are infinite discontinuities. Okay? Okay, so now the reciprocal of 1 is 1. The reciprocal of -1 is -1. So these are easy points to identify. And so far, that's everything I need to do, except I need to grab the shape of this thing. Okay, so here's the logic. Again, as these values, y values, get smaller and smaller, their reciprocals get bigger and bigger. Like right here, if this y value is 1/2, the reciprocal is actually at 2. Same thing here. And I'll just use that as enough of a guide. Okay, and then reciprocals of negatives are negative. So what I do is I use the asymptotes as guidelines, and I just start at whatever these maximum and minimum values are, and then just go. Okay, so head for the asymptotes. Do not cross the asymptotes. Every now and then, I'll get somebody who will, they'll do this, and then they won't do the asymptotes, and they'll graph something like this. Well, dude, these can't cross. Okay, so that's pretty much out. Use the asymptotes, draw the asymptotes, dotted lines for the asymptotes, and then sketch between them. Okay, head for the asymptotes. If you notice, this one's a little wider, this one's a little more narrow. It's supposed to be a little wider. It's supposed to be wherever this was is at 2 now. Whatever the y value 1/2 is at 2 now. I'm not going to be that picky. Okay, so nice and curved, whatever. Okay. So that basic shape. Okay, now the only other thing we have to do is, if you notice, there's a 2 here that multiplies the y values. Well, this should have been 1. It's now going to be 2. This divides the x values. So, for instance, the period was 2 pi. Now it's going to be 2 pi over 5. Okay, so period for sine is 2 pi normally. So this period, 2 pi over b, just like sine and cosine. Tangent is the only one, tangent and its reciprocal, tangent and cotangent, are the only ones that have a period that starts out as pi, so therefore pi over b. Okay, so I'm just going to divide all of my x values by 5. So over 5, over 5. Ta-da! Done. Okay, now I do have some questions to answer, so let's go ahead and do that. Okay, so domain. Again, this is the hard part because it's all about those crazy asymptotes. First asymptote happened, well, at pi over 5. Or if you want, you could say 0, because there was an asymptote at 0. I like that one. And then how far apart are they? Well, they were at 0, pi over 5, 2 pi over 5, 3 pi over 5, 4 pi over, okay, you get the idea. Well, these numbers in the top are just counting by ones. So could we just say pi over 5k, or if you'd prefer, you could write k pi over 5. That looks more like this arrangement, and it's 0 plus, so the 0 really doesn't have to be there this time. Okay. Asymptotes, those values, x equals. Okay, so the basic format for this is whatever the first asymptote one is, plus how far apart they are, times k, which is an integer, which just takes on any integer value. So the idea is you're representing all of the integers in the universe by writing k. Okay, k, period was 2 pi divided by 5 because it was 2 pi over b. Okay, there's that b. Okay. Okay, amplitude and range. Well, amplitude, what's the maximum of this graph? Well, it keeps going up forever. There is no maximum. Okay, so there's none. Okay, you could argue that it's again infinite. I'm just going to write none, or not applicable if you prefer. Okay, range. Okay, remember that this sine function was not really here. I know I did this last time too, but the whole idea is that we just use the sine as a guideline to make these little parabola U-looking things. Okay, so really the graph is these red things. Okay, that's really the graph. Okay, so the range really is from 2 and above and from -2 and below. If you would prefer, you can write this -infinity to -2. It includes the -2. Infinity is never included. This U thing means or. If you want to write the word or, you may. And there you go. All right, we've answered everything. I'd like to do just one more, and I'll try and boogie on. And this one is going to be a cotangent. That's the only one we haven't done at all through this video or the last video. Okay, cotangent is the reciprocal of tangent. So I'm going to do a speedy version of tangent first. Okay, so y equals tangent. Okay, remember at pi over 2 there's an asymptote because the slope of a 90-degree or vertical line is undefined. There we go. And similar on this side. Okay, that's one cycle. Let me do one more. Okay, next asymptote here, so that's pi over 2. This is 2 pi over 2, 3 pi over 2. Okay, so the odd pi over 2s are where the asymptotes start out. This is the parent function. I'll fix it in 2 shakes. All right, that's tangent. Clean tangent, nothing else going on tangent. Okay, you are not going to like this because it's going to have asymptotes everywhere. Okay, just one. Okay, so we're going to now look at reciprocals. Remember that cotangent is the reciprocal of tangent. So I'm going to do some flippage here. Okay, so again, the reciprocal of the y values. Well, the y value here is 0. Again, just like for secant and cosecant, I'm going to do the reciprocal of those zeros first and make a whole bunch of undefined. So in other words, they are now asymptotes. Okay, and this would have been a 0 for tangent again. I just want to have something that looks kind of pseudo-normal once we're done. Okay, and then the reciprocal of undefined is going to be 0. Okay, so what used to be an asymptote for tangent is now a 0. So they kind of swap. Okay, so what used to be an asymptote for tangent is now a 0. What used to be a 0 for tangent is now an asymptote. Okay, look at the blue graph to get your y values. Now, so this point had a y value of 1. The reciprocal of 1 is 1. The reciprocal of -1 is -1. So this is enough for me to know what's going on. I have, look at the red, I have asymptote, and then I'm going through these points to draw this asymptote. Okay, reciprocal of 1 is 1. And it looks, oop, I missed. Something like that. And reciprocal of 1 is 1. Reciprocal of -1 is -1. Okay, so that is the graph of cotangent. And this is crazy because we got blue and red kind of intercrossing, and that makes it harder to see what's going on. Okay, and I apologize for that, but that's just part of it. Okay, one last thing to do, and that is we need to divide all of the x values by 3. So this used to be -pi over 2. Now it's -pi over 6. So pi over 6, I'm just dividing by 3. So 3 pi over 6, I'm going to write that as pi over 2. Okay. All right, so we just need to list some information here. Domain. X not equal to wherever the asymptotes are. Well, we're looking at the red ones. So the first one is at 0. The next one is at pi over 3. The next one is at pi over 2, also known as 3 pi over 6. Harder to see what's going on. This is 2 pi over 6, 3 pi over 6. I don't like that. So pi over 3. No, that was wrong, all that last stuff I just said. Okay, so pi over 3 is the first one. The next one would be at 2 pi over 3 out here. If you notice from here to here, that's pi over 6 minus negative pi over 6 is pi over 3. Okay, so they are pi over 3 apart. The first one was at 0. Okay, go back and look at that again because I know that got confusing. Asymptotes are the same values. I'm just watching the clock, so sorry. Okay, range. Well, these go top to bottom, infinity down to negative infinity, so again, that's all real numbers. Amplitude, since it's infinite, is none, or again, if you want to write infinity, you can. And period was pi divided by 3. Again, tangent starts out as pi, and this cotangent is based on that, and over 3. All right, that last one, kind of crazy. It gets ugly, and I went fast. Sorry. All right, I got to go. SanfordFlipMath, another time.